Welcome to our first attempt at flipping the Algebra 2 classroom with Mrs. Roberts. I wanted to welcome you this evening and hope that you're excited about this endeavor as I am. We're going to spend 2 days on section 8.6 with radical expressions and rational exponents. So we're going to walk through this really carefully so you can understand the expectations that I have of you. Today we're going to talk about simplifying radical expressions, and that's all we're going to worry about today. There are some vocab words that we need to write down. One of them is just an expression. It's the nth root of a. It's written as n with a radical sign and an a. The n is a little number outside the radical sign, and n is considered the index or the root. We've already seen these with square roots, only we don't usually write the 2 there for square roots. The radical expression is another vocab word that we have. It's a group of terms that involves a radical sign. Pause this for a moment if you need to write these down, and we'll pick up with some more vocab words, or actually some key properties here in just a minute. One of the key properties is the product property. It says that radicals with the same index or root can be multiplied under the radical. This is what's key here. It has to be the same index or root. If they are not the same index or root, we cannot multiply under the radical sign. And the same thing works with quotients or division. It says radicals with the same index or root can be divided under the radical sign. And so we're going to look at a few examples and we're going to simplify these things here. Again, pause this if you need to be able to get these written down. I will be looking for these things in your notes tomorrow. Okay, here are a couple of our examples. The first one we're going to start with says the fourth root of 81x to the 12th. This is our index right here. That number 4 is our index. That tells us how many times we're looking for that group. Do you remember when we talked about simplifying square roots and we said we were looking for pairs to go to the movies? Well, now we're looking for groups of 4 because our index tells us how many we're looking for. So we're going to take this 81 and we're going to break it down just like we did with the square root. So we're going to break 81 down into 9 and 9. But 9 can be broken down further. So we're going to break 9 down into 3 and 3. And we're going to break this 9 into 3 and 3. Right? Now this fourth index here, or this fourth root, says I am looking for a group of 4 to go to the movies together. Do you remember how we explained that when we were doing the square roots? Right? Well, there are 4 3s. So that means that I have 1 3 that gets to come outside the radical sign. Now this x to the 12th, we're going to do that in the same way. X to the 12th means I have x 12 times. Let's see if I can fit all these in here. There's 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I look back to my root to tell me how many I need in a group. I need 4 in a group, so there's one group of 4. I need another 4 in a group, so there's another group of 4. And I need another 4 in a group, so there's a last group of 4. How many groups of 4 do I have? I have 3. So that says I have x to the 3rd power. So that says 3x to the 3rd power. If I multiplied that out 4 times, I would get back to this 81x to the 12th. Well, let's think about that. 3 times 3 is 9, times 3 is 27, times 3 is 81. X cubed times x cubed times x cubed times x cubed would give me x to the 12th. Okay? So now I want you to look at this one down here. The fourth root of 16x to the 4th. Pause it, try it yourself, and then come back and let's see if you did it correctly. Okay, let's practice and see. Again, we've got the same the same root. We have the fourth root. So we're going to break 16 down into 2 times 8. I could have broken that down other ways, but I chose to do 2 times 8 today. Then we're going to break 8 down into 2 times 4. And we're going to break 4 down one more time into 2 times 2. Now, this fourth root says I need a group of 4 to go to the movies. There is one group of 4. So that's going to come outside. Now this x to the 4th. I have 1, 2, 3, 4. I have 4 in a group. I have one group of x's. So my answer is 2x. Did you get that? Can you think about what the rule might be for this power here and this root here? Let's see if we can do some more examples. Okay, here's where we're going to use the multiplication property, or that product property. It says we can multiply these two if the root is the same. This is a cube root, and this is a cube root. So we can multiply both of those. And remember, when we multiply the variables. And when we multiply variables, we add their exponents. So this still stays the cube root, nothing changes outside of it. And now I have x to the 7th times x squared. You could even write it like this if you wanted to at first. Let me get that x a little bit better there. Okay. Now, this is from our rules of exponents. When we are multiplying like variables, what do we do to these exponents? We add them. So that's x to the 9th. All right. So now we need to simplify the cube root of x to the 9th. If you need to break it down, you can write x out 9 times. Now that's going to get a little cumbersome here for us. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that's not a very good x there. There we go. And we're looking for groups of 3. Well, there's one group of 3, there's 2 groups of 3, and there's 3 groups of 3. So our answer would be x cubed. Are you starting to see a pattern here? I hope so, because we're going to talk about that pattern tomorrow in class and see what we can do with it. Okay. Now, you try this one. First, ask yourself, is that the same root? Are we taking the same root of y to the 5th and y cubed? Okay, pause this, try it, and let's see if your answer comes out to be the same as what we get when we work it through together. Okay, let's take a look at this. We have the 4th root of y to the 5th and the 4th root of y cubed. Same root, so we can multiply under the radical sign. Still need that 4th root out here. So we have y to the 5th times y to the 3rd. Too many equal sign there. When we multiply, again, we add the exponents. So we now have the 4th root of y to the 8th. Now, if I were to tell you that that was y squared without writing those out, could you come up with the rule to figure this out? Let's see, we have y to the 8th I think that's 8. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. And I need groups of 4 to go to the movies. There's a group of 4, and there's a group of 4. How many groups of 4 do I have? 2. So that's why it's y squared. Okay? We're going to keep working with these. We've got a couple more problems that we're going to do. And they're just going to get a little bit more. Okay, we also have to look at the quotient property. And the quotient property simply means when you're dividing. And you can be dividing with both things under the radical, or you can be dividing with 2 radicals on top of each other. We're going to look at it both ways. This first way we're going to look at is when both of them are under the radical. It's the same thing. It says the cube root of x to the 7th divided by x to the 4th. Well, what do we do when we divide exponents? Right, we subtract them. Excuse me, what do we do when we divide variables? We subtract their exponents. And so x to the 7th divided by x to the 4th becomes x to the 7 minus 4, or x cubed. Well, that's 3 x's. 1, 2, 3. So I need a group of 3 x's to be able to go to the movies. Here's my group of 3 x's. What is the cube root of x cubed? It's simply x. Now, this one is very similar. except the two fifth roots are not under the same division symbol, but we can rewrite that as the fifth root of x to the 13th over x to the 8th. Now it's just like what we did up there. We say x to the 13th divided by x to the 8th. When we have like variables, we subtract their exponents. So that is the fifth root of x to the 5th, which should give us, again, just x. Let's think about that. We've got 5 x's here. I have a group of 5 that need to go to the movies. How many get to go to the movies? One group of 5, and so it's x to the first power, just x. It's here when we simplify this one. Let's go ahead and break down the 32. I can get my pen to move up here for us. All right, 32. It can be factored into 8 times 4. 8 can be broken down into 4 times 2. And 4 can be broken down into 2 times 2. And we're going to break this 4 down into 2 times 2. Oops, that one's kind of a little close there. All right. Now, this is our index. This is our root. It says the fourth root of 32. Well, the fourth root of 32 says I need a pair of 4. I need a group of 4 of the same number. Well, there's 1, 2, 3, 4 2's that get to go to the movies. But what happens to this guy? Do you remember from when we did square roots? What happened to him? That's right, he has to stay home. So we write down the 1, 2 out here. Oops, we're scribbling a little bit here. Just a minute, let me erase that. Okay, and let's try this again. Okay, all right, so we wrote down the 1, 2 that gets to go to the movies, but we still have that 2 that has to stay home because it didn't have enough partners to go to the movies with. It needed 3 other partners and it didn't have that. That's going to be a little close together. Let me try that again here. Just going to slide that over a little bit. All right, I'm going to move this over just a little bit if I can get my pen to cooperate again. So I've got the fourth root, and the 2 had to stay home. Now we have x to the 11th here. That means I have 11 x's here. Let's change this color to the blue. There we go. All right, so we have 11 x's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're looking for groups of 4 to go to the movies. So here's a group of 4. Here's a group of 4. And do I have enough left over to form another group of 4? I don't. So what that means is I get to send 2 groups to the movies, and 3 of those x's have to stay home. So can you see what happens? Sometimes we don't have a perfect fourth root, or a perfect square root, or a perfect cube root. And it's just like we were doing before. We said 2x squared times the fourth root of 2x cubed. If there's enough in the group to go to the movies, they get to come out. If there are not enough in the group, they have to stay home. And remember, our radical sign is our home. All right, I want you to try this one. Pause it, try it on your own, and see if what you do matches what I get. All right. Did you pause it so you could do it? Let's take a look at this 64 here. We're going to break this down. 64 can be written, excuse me just a second here. 64 can be written as 8 times 8. Okay. 8 can be broken down as 4 times 2. And this 8 can also be broken down as 4 times 2. This 4 can be broken down further as 2 times 2. And this 4 can be broken down further as 2 times 2. Okay. Now, I need a set of 4 in a group to go to the movies. Well, here's 4 2's, so they get to go to the movies. But this 2 and this 2 have to stay home. So I have one set of 4 2's out here write this here. But these two 2's don't get to go to the movies. They don't have enough partners. But remember, we were multiplying those, so we have to multiply those under the radical as well. All right, so now x to the 16th. That's a lot of x's to write. So I'm going to do it this way. Maybe. All right, let's try doing it like this. If we can. It's not wanting to cooperate for us here. All right, let's see what we can do here. So we've got x, we've got 16 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 x's. So we have 16 x's. Now remember, our index up here says we need 4 in a group. So let's see if we can find our 4 in a group. There we go. All right, so here's 4, here 4, here 4, and here are 4. We have exactly 4 groups of 4. So this is 4 groups get to go to the movies. That's our exponent. There is nobody left at home. But we can multiply under this radical here. So this is 2x to the 4th times the 4th root, and 2 times 2 is 4. And so that would be our answer. Is that what you got? I hope so. All right, let's try just a few more problems here. All right, these two I want you to try on your own, and then we'll check back and see how you did. Notice they're different roots this time. We've been working with 4th roots. This is the 3rd, or the cube root, and this is the 5th. We'll just call it the 5th root. We don't have a special name for it. All right, so pause this, try these two on your own, and let's see how you do. Okay, so we're going to break down the 54. 54 can be written as 2 times 27. 27 can be written as 3 times 9. And 9 can be written as 3 times 3. Okay. Now, this x to the 6th can be written as 6 x's. Let's see if, again, I can get this to cooperate here. All right, let's try it this way. We'll look at it all at once. So I have 6 x's. 1, 2, 3, 4, 5, 6. Now, we're looking for that 3rd root, or the cube root, so we're looking for a group of 3. So let's go back and get my pen here. Okay, so now we need the cube root of 3. Excuse me, the cube root of 54, and we're looking for a group of 3. Well, I have these 3 3's. They form a group. So they get to go to the movies. But this 2 has to stay home. So he's going to stay under the radical sign. Don't forget to put your index there. Now I have 3 x's here, and I have 3 x's here. So this is how many groups of x's get to go to the movies? 2 groups, and that's our exponent. Okay. Now let's take a look at this bottom one. Did you try it? So we're going to type this x to the 7th out. This is the 5th root of x to the 7th and y to the 14th. And so we're going to type this out so it's a little bit easier for us to look at. So we have 7 x's, 1, 2, 3, 4, 5, 6, 7, and 14 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 y's. Okay, now we're going to look, since this is a 5th root here, this is a 5th root, we're looking for sets of 5. So 1, 2, 3, 4, 5 x's here. This is not enough to make another set. So we're going to say that this equals, again, we need to make sure we put our index outside when we write that, but that's a little too early. I need to write the one group of x to the 5th, one group of x's out here. Okay. So this is one group of x's. and there are 2 left at home. Remember, our home is our radical sign. Since we have 2 of them left, it's x squared. Now we're still looking for a group of 5 y's. 1, 2, 3, 4, 5. There's a group of 5 y's. And we've got another group of 5 y's. 1, 2, 3, 4, 5. But this is not enough to make another group of 5 y's. So we have those that have enough partners to go to the movies. They get to come out, and there are 2 groups of those. So that's y squared. And there are 4 y's that are left at home. So that's y to the 4th power. Okay, and so your answer should have been for that one, x y squared times the 5th root of x squared y to the 4th. How'd you do? Did you get all those right? I hope so. All right, so now that's the end of our lesson. Here's what you need to do to prepare for class tomorrow. You need to summarize what you've learned. Did you come up with any tricks on how to make those exponents any easier when you're dealing with variables? We're going to talk about that tomorrow, but I want to know what you thought. I want you to summarize that. Do you have any questions for me that we still have to answer? That's another thing I want you to write down. Again, I'll be looking for all these examples tomorrow, and you'll have a chance tomorrow to work some problems and show me what you've learned. And then you'll have time in class tomorrow to work the problems. Look forward to seeing you then. Good night.